All right, all of you. Chalo. Now we go into the very interesting concept called as chemiosmotic hypothesis. Now it is given very, very badly in the NCERT, and even in our notes, we have just given a little understanding. So I'm going to send you all this PDF file, और इस PDF फाइल के अंदर ये वाला डायग्राम बहुत ध्यान से समझना. This is not given in any book. MTG अरिहंत कहीं 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 कुछ दिया नहीं है. Nowhere it is given. Please understand this. और ये वाला जो डायग्राम है ना, ये आप लोग इसका एक प्रिंट आउट निकाल के अपने नोट्स में चिपका देना या अपनी एनसीईआरटी बुक में चिपका देना. वेरी ब्यूटीफुल कंसेप्ट. बहुत ध्यान से प्लीज अंडरस्टैंड दिस. व्हाट विल एक्चुअली हैपन? प्लीज फोकस ऑल ऑफ यू. In the matrix, you have NAD becoming NAD, rather NADH plus H plus becoming NAD, and hydrogen will go to FMN, which will then become FMNH2, and then it will go into something called FES. Now this is the real thing. Last lecture भी बताया नहीं था मैंने. So where has hydrogen gone? Hydrogen has gone from NADH plus H plus to FMN, then to FES. From FES, it has gone to ubiquinone, which we remember is coenzyme Q. Coenzyme Q is called ubiquinone. From ubiquinone, it goes to coenzyme QH2, which is called ubiquinol. So ubiquinone becomes ubiquinol. In other words, coenzyme Q becomes coenzyme QH2. And then electrons, if you remember, coenzyme QH2 में से hydrogen will split to form protons and electrons. And electrons will first pass into cytochrome B. From cytochrome B, it will go to FES. तो वापस ये कुछ नया है. FES. From FES, it will go to cytochrome C1. From cytochrome C1, it will go to cytochrome C. From cytochrome C, it will go to cytochrome C, will go to cytochrome A, which we remember is a copper compound. From cytochrome A will go to cytochrome A3. From cytochrome A3 will go to, again, copper enzyme. And cytochrome A3 say it will go to oxygen, and oxygen with water, oxygen with electron and proton combine together to form water, which is called water. And that phenomenon is called as terminal oxidation. So once again, where has the actual flow been? बहुत ध्यान से. Hydrogen has gone from NADH plus H plus H plus to FMN. वो तो हम लोग ने last time किया था. From FMN, where does it go to? FES. From FES, where does it go to? Coenzyme Q, which is called as ubiquinone, to coenzyme QH2, which is called ubiquinol. From there to cytochrome B. From cytochrome B to FES. From FES to cytochrome C1. From cytochrome C1 to cytochrome A. From cytochrome A to cytochrome A3. From cytochrome A3, again it is copper containing. It will go to oxygen and combine with proton to form water, which is called terminal oxidation. So once again, NAD से कहा गया है FMN, FMN से कहा गया है FES. ये कुछ नया किया हमने आज. FES. FES say it will go to ubiquinone, which is coenzyme Q, to ubiquinol, coenzyme Q H2, to cytochrome B, again to FES, to cytochrome C1, from cytochrome C1 to cytochrome A to cytochrome A3 to copper containing, so CUB, CUA, CUB is copper containing, to half oxygen combined with proton to form water, which is called terminal oxidation. Now, this is the real logic. And बहुत ध्यान से, when याद है NAD और FMN के बीच में एक ATP बनाया हमने, एक ATP बनाया, which we called complex 1. NAD and FMN के बीच में एक ATP बनाया, which is called complex 1. Now actually वहां ATP नहीं बना है, ATP नहीं बना है वहां पर, वहां सिर्फ इलेक्ट्रॉन में से एनर्जी लिबरेट हुई, इलेक्ट्रॉन से एनर्जी लिबरेट हुई, which removed protons, जिसने प्रोटॉन को पुश किया, प्रोटॉन को पुश किया. करेंगे हम लोग आगे ये. And then from ubiquinone to ubiquinol and then to cytochrome B to cytochrome C1. याद है हमने बताया था cytochrome B to cytochrome C1 एक ATP बनता है, which is called complex 3. But actually उसमें ATP नहीं बनता है, उसमें सिर्फ इलेक्ट्रॉन की वजह से protons are pushed out. Protons are pushed out, and protons will form energy later. And cytochrome C से cytochrome A to cytochrome A3, and cytochrome A और A3 के बीच में और एक ATP बनाया था हमने, cytochrome A और A3 के बीच में एक ATP बनाया था, that we call complex 4. But actually no, same thing. इलेक्ट्रॉन्स के अंदर से एनर्जी निकल के protons are pushed out. Protons are pushed out. And protons go into something called intermembranous space. और उसमें से ATP बनता है. तो ध्यान से NAD-FMN के बीच में ATP नहीं बनता है, प्रोटॉन पुश आउट होता है, प्रोटॉन पुश आउट होता है. और B और C1 के बीच में ATP नहीं बनता है, प्रोटॉन पुश आउट होता है, प्रोटॉन पुश आउट होता है. और A और A3 के बीच में ATP नहीं बनता है, सिर्फ प्रोटॉन पुश आउट होता है, प्रोटॉन पुश आउट होता है. हाँ, तो these protons will form energy, ATP, which is called complex 1, complex 3 and complex 4. But between FAD, अभी ध्यान से, succinate to fumarate, succinate to fumarate, FAD is formed, and FAD will now become iron sulfur. FAD will become iron sulfur, which will then become ubiquinone to become ubiquinol. So याद है, FAD become FADH2, FADH2 again become FAD. From FAD where does hydrogen go to FES. तो ये कुछ नया है. NAD से भी एक्चुअली कहा गया FMN, FMN से गया FES. Similarly, FAD से it first went to FES, then to ubiquinone, then to ubiquinol. और इस प्रोसेस में from ubiquinone, ubiquinol, that is from coenzyme Q to coenzyme QH2. From coenzyme QH2, what will happen? hydrogen will split to form proton and electron. And where is electron given to? Electron is given to cytochrome B to cytochrome C1. Cytochrome B to cytochrome C1. But ध्यान से FAD to FES to ubiquinone to ubiquinol till cytochrome B हाइड्रोजन ट्रांसफर हुआ, बट उसमें प्रोटॉन पुश आउट नहीं हुआ. प्रोटॉन पुश आउट नहीं हुआ. अगर प्रोटॉन पुश आउट होता है, then it will form ATP by something called chemiosmosis. अगर प्रोटॉन पुश आउट होता है, FMN2 rather NAD2FMN प्रोटॉन पुश आउट हुआ, then it will undergo something called chemiosmosis, जिससे ATP बनता है. Similarly, between B and C1 प्रोटॉन पुश आउट होता है, which is called chemiosmosis 2, उससे ATP बनता है. Similarly, A और A3 के बीच में प्रोटॉन पुश आउट होता है एंड उससे chemiosmosis 3 होता है, उससे भी ATP बनता है. तो प्रोटॉन chemiosmosis 1 ATP, प्रोटॉन प्रोटॉन chemiosmosis 2 उससे भी ATP, प्रोटॉन chemiosmosis 3 उससे भी ATP. But from succinate to fumarate, FAD से FES, FES से ubiquinone, ubiquinone से ubiquinol, उससे डायरेक्टली साइटोक्रोम बी. उस प्रोसेस में प्रोटॉन पुश आउट नहीं हुआ. No proton pushing out, so no chemiosmosis. No chemiosmosis. And what is that called as? Complex 2. तो complex 2 में chemiosmosis नहीं होगा. complex 1 में chemiosmosis होता है. complex 3 में chemiosmosis होता है. complex 4 में chemiosmosis होता है. chemiosmosis होता है. So complex 1 में प्रोटॉन पुश आउट होता है तो chemiosmosis होता है. complex 3 में B2C1 प्रोटॉन पुश आउट होता है, chemiosmosis होता है. complex 4 में A2A3 प्रोटॉन पुश आउट होता है, in other words chemiosmosis होता है. But complex 2 में FAD2, FES2, ubiquinone 2, ubiquinol 2, cytochrome B1, उसमें प्रोटॉन पुश नहीं होता है. No protons are pushed. No proton is pushed, so chemiosmosis नहीं होता है. चलो, ये आपने थोड़ा थोड़ा समझा है. अब एक्चुअली समझते हैं. This is not given any book, all of you. Please understand this thoroughly well. बहुत ध्यान से सुनना, बहुत ध्यान से. Sir, from NADH plus H plus, 2 hydrogen became NAD and 2 hydrogens were accepted by FMN to form FMNH2. And there was from NADH plus H plus to NAD, जो 2 हाइड्रोजन गए उससे FMN became FMNH2. उसमें हाइड्रोजन gave away energy, and hydrogen gave away energy, and in the matrix are found protons. In the matrix are found protons, and याद है NADH plus H plus, when it gives away hydrogen, hydrogen में बहुत energy होती है, and that energy is trapped by proton. That energy is trapped by proton in the matrix, and protons go from the matrix into the intermembranous space. What is this space called as? Intermembranous space, which is the space between the outer and the inner mitochondrial membranes, which is the space between outer and inner mitochondrial membrane. उसके बीच की जो space है, this space is called as the intermembranous space. So once again, NAD to NADH plus H plus gives away 2H. 2H is accepted by FMN to form FMNH2, and 2H releases energy, and that energy is accepted by proton in the matrix, and protons will move from the matrix into the intermembranous space. So intermembranous space में क्या आ गया? Proton. Intermembranous space में क्या आ गया? Proton. All of you clear? Now ध्यान से NAD to FMN, प्रोटॉन में से एनर्जी, प्रोटॉन विथ एनर्जी गो इनटू द इंटरमेम्ब्रेनस स्पेस. ये है इंटरमेम्ब्रेनस स्पेस. देन ध्यान से, तो दिस इज कॉल्ड कॉम्प्लेक्स 1. सो कॉम्प्लेक्स 1 में हमने क्या किया है? पुशिंग ऑफ प्रोटॉन्स. कॉम्प्लेक्स 1 में हमने क्या किया? पुशिंग ऑफ प्रोटॉन्स. If you go back to this diagram, complex 1 में हमने क्या किया? Complex 1 में हमने किया pushing of protons. Pushing of protons is called chemiosmosis. Pushing of proton. That was complex 1. Back to the diagram. From FMNH2, hydrogen will go to coenzyme Q. And coenzyme Q will form coenzyme QH2. In other words, ubiquinone will become ubiquinol. That we remember. And coenzyme Q will become coenzyme QH2. Coenzyme QH2 में से again coenzyme Q बन जाएगा. 2 hydrogens are given out. Hydrogen with energy will split to form protons and electrons. Once again, NADH2 to NAD. 2 hydrogen were given out. उसमें से थोड़ी energy के साथ protons were pushed into the intermembranous space. So there are already protons in the intermembranous space. And this hydrogen was accepted by FMN to form FMNH2, which then combined with coenzyme Q to form coenzyme QH2. And hydrogen from coenzyme QH2 became coenzyme Q. Hydrogen split to form proton and electron, of which energy goes into electron. Where will protons remain? Protons will remain in the matrix. Where will electrons go? Electrons will pass from the matrix into the inner mitochondrial membrane. And inner mitochondrial membrane में electrons are accepted by electron acceptor. तो ये है inner mitochondrial membrane और ये है electron. And electron कौन accept करेगा? Electron is accepted by. अच्छा, where will proton remain in the matrix? Where will electron go into the inner mitochondrial membrane? Inner mitochondrial membrane में electron will pass into electron acceptor BC1CA3. ये हमने किया है. अब ध्यान से, when electron will go, first it is accepted by B. and electron is rich in energy. Electron is rich in energy. तो B से C1 में जब जाएगा इलेक्ट्रॉन, थोड़ी सी एनर्जी will go along with the proton, and proton will go from the matrix into the intermembranous space, and that is called complex 2. उसे कॉम्प्लेक्स 2 कहते हैं. तो कॉम्प्लेक्स 2 में क्या हुआ? ट्रांसफर ऑफ एनर्जी एंड इलेक्ट्रॉन बिटवीन B एंड C1. B और C1 के बीच में जब इलेक्ट्रॉन पास हो रहा था बिटवीन B और C1, तो इलेक्ट्रॉन में से एनर्जी लिबरेट हुई, एंड दैट एनर्जी combined with proton, and proton went from matrix into the intermembranous space. Intermembranous space. This is called complex 2. तो BC1 से भी proton push out हुआ, which is called complex 2. So if we go back to the diagram, BC1 से वापस proton push out हुआ. That is called complex 3. I'm so sorry. This is called complex 3, all of you. I'm so sorry. Yeah. ये है complex 3. Yeah. Okay. So BC1 के बीच में क्या था? BC1 के बीच में complex 3. BC1 के बीच में complex 3, उससे प्रोटॉन पुश हुआ. That is called as complex 3. So ध्यान से NAD2FMN हाइड्रोजन ट्रांसफर में प्रोटॉन with energy went into intermembranous space, and that was called complex 1. और B2C1 में वापस प्रोटॉन विथ एनर्जी, इलेक्ट्रॉन went from B to C1, वापस प्रोटॉन विथ एनर्जी was pushed into the intermembranous space. That is called complex 3. And then electron went from C1 to C, C to A, A to A3. So whereas electron gone from B to C1 to C to A to A3, उसमें दो प्रोटॉन पुश हुए from electron transfer from B to C1. Those protons got pushed into the intermembranous space, जिसे हमने बताया complex 3. And now from A to A3, if you remember, A to A3 में वापस इलेक्ट्रॉन्स लिबरेट एनर्जी. इलेक्ट्रॉन में से लिबरेट होती है एनर्जी. That will again push protons into the intermembranous space. तो उससे भी प्रोटॉन्स A to A3, ध्यान से A to A3 में इलेक्ट्रॉन्स will again liberate energy. That will again push proton into the intermembranous space. So this is called complex 4. इसे कहते हैं complex 4. So again in the diagram, from A to A3, what was pushed out? Proton, and that is chemiosmosis 3, which is called complex 4. And check it here, all of you. तो हमने कितनी बार प्रोटॉन पुश किया फ्रॉम NAD to FMN? हाइड्रोजन से हमने एनर्जी के साथ प्रोटॉन को पुश किया इंटरमेम्ब्रेनस स्पेस में, एंड दैट इंटरमेम्ब्रेनस स्पेस में first proton pushing was between NAD to FMN. What is that called as? Complex 1. वो हो गया complex 1. Then from B to C1, again protons were pushed. That is called complex 3. Complex 3. And A to A3. A to A3. Again protons are pushed into intermembranous space. And वापस proton push हुआ in the intermembranous space. Into intermembranous space. That is called complex 4. Complex 4. So कौन-कौन से complexes हो गए? कौन-कौन से complexes हो गए? NAD to FMN में proton with energy is pushed into intermembranous space. That is called complex 1. Complex 1. Then from B to C1, again proton is pushed into the intermembranous space. That is called complex 3. Complex 3, B to C1. तो NAD to FMN कौन था? Complex 1. Complex 1. And B to C1 के बीच में कौन हो गया? Complex 3. Complex 3. और A to A3 के बीच में वापस proton got pushed. वापस proton got pushed into intermembranous space. Into intermembranous space. What is that called as? A to A3 is called as complex 4. A to A3 is called complex 4. So golden word. NAD FMN के बीच में ATP नहीं बनता है. NAD FMN जो अपनी ETS में लास्ट टाइम किया था ना, उसमें ATP नहीं बनता है. उसमें क्या होता है? प्रोटॉन पुश होता है. प्रोटॉन पुश होता है विथ एनर्जी इनटू द इंटरमेम्ब्रेनस स्पेस. उतना ही होता है. एटीपी नहीं बनता है. सिमिलरली बिटवीन बी और C1 एटीपी नहीं बनता है. ओनली प्रोटॉन पुश होता है इनटू इंटरमेम्ब्रेनस स्पेस. सिमिलरली ए और A3 के बीच में एटीपी नहीं बनता है. सिर्फ प्रोटॉन पुश होता है into the intermembranous space. So all the three complexes, NAD FMN के बीच में complex 1 was pushing of proton with energy into intermembranous space. Intermembranous space. B to C1 complex 3 के अंदर there is pushing of protons into the intermembranous space. And A और A3 के बीच में again there is simply pushing of protons into the intermembranous space. So these are complex 3. ये हो गए complex 1, complex 3, complex 4. NAD और FMN के बीच में कौन बन गया? पुशिंग ऑफ प्रोटॉन इज कॉल्ड कॉम्प्लेक्स 1. B और C1 के बीच में पुशिंग ऑफ प्रोटॉन इनटू इंटरमेम्ब्रेनस स्पेस इज कॉल्ड कॉम्प्लेक्स 3. और A और A3 के बीच में पुशिंग ऑफ प्रोटॉन इनटू इंटरमेम्ब्रेनस स्पेस इज कॉल्ड कॉम्प्लेक्स 4. तो ये कॉम्प्लेक्स 1, कॉम्प्लेक्स 3 और कॉम्प्लेक्स 4 ऐसे 3 कॉम्प्लेक्सेस बन गए. सो नाउ वी हैव अंडरस्टूड दिस डायग्राम एक्चुअली कि FMN और NAD और FMN के बीच में क्या हुआ? पुशिंग ऑफ प्रोटॉन इनटू द इंटरमेम्ब्रेनस स्पेस. पुशिंग ऑफ प्रोटॉन इनटू इंटरमेम्ब्रेनस स्पेस. And then from B to C1 there was pushing of proton into the intermembranous space. Pushing of proton. And A और A3 के बीच में क्या था? Pushing of proton into the intermembranous space. So what are all the 3 complexes? Complex 1, NAD और FMN के बीच में pushing of protons into the intermembranous space. What is B to C1? Pushing of protons into the intermembranous space. That is complex 3. And what is complex 4 between A2 A3 pushing off protons into the intermembranous space? हाँ, pushing off proton कब नहीं हुआ? Succinate to fumarate, FAD to coenzyme Q to cytochrome B, उसके अंदर pushing of protons नहीं हुआ. Pushing of protons नहीं हुआ. So there is no chemiosmosis. No chemiosmosis. And that is called as complex 2. तो complex 2 में chemiosmosis नहीं है. Complex 1 में first chemiosmosis है. Complex 3 में second chemiosmosis है. Complex 4 में third chemiosmosis है. लेकिन complex 2 में pushing of proton नहीं होता है. So there is no chemiosmosis. No chemiosmosis. Now let's understand what actually happens. Now let's understand what actually happens. Sir, protons have gone into the intermembranous space with energy. Protons have gone into the intermembranous space with energy. Proton गए with energy. If you remember, NAD2, FMN, hydrogen was accepted, but it gave away proton with energy. Similarly, B और C1 के बीच में protons went out with energy. And A और A3 के बीच में protons went out with energy. So all these protons in the intermembranous space, protons in the intermembranous space, protons in intermembranous space are rich in energy. Protons in intermembranous space are rich in energy. They have a lot of energy. And what will happen? What will happen now? Protons are in intermembranous space. In the meantime, ध्यान से हाँ, in the meantime, where had hydrogen gone? Hydrogen had gone from FMN to FMNH2. Actually, hydrogen had gone from NADH2 to NAD, जिससे hydrogen went to FMN to FMNH2. Then it went from coenzyme Q to coenzyme QH2. In the meantime, 2H split to form proton and electron, of which electron pass from B to C1, C to B to C1, C to A to A3. And what happened in the meantime? ये प्रोसेस के अंदर प्रोटॉन निकल गए NAD और FMN के बीच में इंटरमेम्ब्रेनस स्पेस में. That is complex 1. And B और C1 के बीच में वापस इंटरमेम्ब्रेनस स्पेस में. That is complex 3. और A और A3 के बीच में वापस प्रोटॉन went into the intermembranous space. That is complex 4. But eventually electron का क्या होगा? Electron का क्या होगा? Electron has gone from B to C1 to A to A3, and from A3 electrons have now lost all the energy. Electron की सारी energy चली गई. वो BC1 के बीच में थोड़ी चली गई. And protons went into the intermembranous space with energy. And थोड़ी energy electron से B और C1 के बीच में चली गई. और then C और बाकी की एनर्जी इलेक्ट्रॉन की A और A3 के बीच में प्रोटॉन में चली गई. तो एनर्जी इलेक्ट्रॉन से प्रोटॉन में चली गई. एनर्जी इलेक्ट्रॉन से प्रोटॉन में चली गई. तो पहले हाइड्रोजन जो निकला था, हाइड्रोजन से प्रोटॉन एनर्जी लेके इंटरमेम्ब्रेनस स्पेस में आ गया. हाइड्रोजन which was rich in energy, and proton with energy are now found in the intermembranous space. Then it went from FMNH2 to coenzyme Q, and then split to form proton and electron. Proton remained in matrix. Electron passed from B to C1. उसमें थोड़ी एनर्जी प्रोटॉन के साथ इंटरमेम्ब्रेनस स्पेस में चली गई, तो प्रोटॉन इज विथ एनर्जी एंड डी और C1 के बीच में, और फिर A और E3 के बीच में वापस से प्रोटॉन विथ एनर्जी वेंट इनटू द इंटरमेम्ब्रेनस स्पेस. तो एनर्जी थी किसके अंदर? एनर्जी वाज देयर इन इलेक्ट्रॉन. एनर्जी वाज देयर इन इलेक्ट्रॉन, बट फ्रॉम इलेक्ट्रॉन बी और C1 के बीच में और बाद में A और A3 के बीच में, where has energy gone from electron into, from electron energy has gone into proton. From electron energy has gone into proton. So please remember, where has energy gone from? Energy has gone from electron to proton. Energy has gone from electron to proton, and all the energy is now gone from electron to proton. So intermembranous space में कौन है? Proton, which is rich in energy. Proton, which is rich in energy. What will happen to electron? इलेक्ट्रॉन की सारी एनर्जी चली गई BC1 की और AA3 में. Now electron has no energy, and this electron will combine with oxygen as the last electron acceptor, and oxygen with the electron goes back into the matrix, and in the matrix oxygen with electron without any energy now. Energy to already has gone in the proton. Energy has gone in proton. Electron without energy combines with proton which was there in the matrix. याद है जब coenzyme QH2 became coenzyme Q, 2H split to form protons and electrons, of which electrons went from BC1 C to A to A3, eventually combined with oxygen electron and returned back. What was already present in the matrix? Proton. And what has just returned back? Just returned back क्या हुआ है? Oxygen with electron. So oxygen with 2 electron has just returned back, and what is already present in the matrix? Proton. Now proton with oxygen with 2 electrons combined with 2 proton. 2 electron combined with 2 proton, so they become 2H. 2H plus 2 electron minus will become 2H. So it will become stable. So ionic becomes stable, and 2H combines with oxygen. 2H combines with oxygen to form water. To form water. That is called as terminal oxidation. That is called terminal oxidation. ATP किधर है? Sir ji, if you remember, now in the intermembranous space there are protons with energy, and these protons with energy have accumulated in the intermembranous space. बहुत सारे प्रोटॉन पुश आउट हुए. कॉम्प्लेक्स 1 का प्रोटॉन पुश आउट हुआ, कॉम्प्लेक्स 3 का प्रोटॉन पुश आउट हुआ, कॉम्प्लेक्स 4 का प्रोटॉन A और A3 का बीच का पुश आउट हुआ. तो कॉम्प्लेक्स 1, 3 और 4 के बहुत सारे प्रोटॉन हैं which are in the intermembranous space, and these protons are rich in energy. And these protons, which are in a massive number, proton with energy, will now come back from the intermembranous space back into the matrix. और प्रोटॉन वापस से मैट्रिक्स में आते हैं. प्रोटॉन गए किधर थे? Proton had gone from matrix into intermembranous space. From matrix, protons had gone into intermembranous space. So now, where will protons go? Protons had gone from matrix into intermembranous space. Intermembranous space. So now, where will proton go? From intermembranous space back into the matrix. So proton gaya, that was root 1, root 3 and root 4. वो proton gaya into intermembranous space. Into intermembranous space. Now, where will protons go from intermembranous space back into the matrix? Back into matrix, back into matrix, back into matrix. H plus, H plus, H plus, H plus. So protons will now go from intermembranous space back into the matrix, back into the matrix. And as these protons go from intermembranous space back into the matrix, where will they pass through? Golden word. If you remember, the entire inner membrane is made up of elementary particle called F1 particle. और now, जब proton return from intermembranous space into matrix, matrix में जाने के लिए where will protons have to pass through? Protons will have to pass through the F1 particle. Proton will have to pass through F1 particle. Protons will have to pass through F1 particle. What is present in the F1 particle? What is present in the F1 particle? In the F1 particle is present enzyme called ATP synthase. And while the proton is returning back into the matrix, ATP synthase enzyme traps that energy. तो प्रोटॉन की एनर्जी is trapped by ATP synthase. ATP synthase will trap the energy, and energy of proton is trapped by ATP synthase. ATP synthase traps the energy, and that energy is combined between ADP and IP to form a molecule of ATP. And that is the reason all the ATPs are actually produced by ATP synthase, which is now called complex 5. And this is called as the chemiosmotic hypothesis. So, hydrogen, NAD2FMN, hydrogen went with energy into the intermembranous space. B और C1 के बीच में proton went into intermembranous space with energy. A और A3 के बीच में proton went into the intermembrane space with energy, and all these were called complex 1, complex 3, complex 4, but eventually ये सब ने ATP नहीं बनाया. Protons remaining with energy when they pass through F1 particle, F1 particle के अंदर था ATP synthase enzyme, और ATP synthase ने एनर्जी को ट्रैप किया, combined it with ADP and IP to form a molecule of ATP. It is ATP synthase which actually produces ATP and is called as complex 5. Perfect. What is this phenomenon called as? Chemiosmotic hypothesis. Brilliant. Chalo, I hope you understood this. Good.